everybody, and welcome back to another video. In this week's video, we're going to learn how to find parallel and perpendicular lines of a linear graph using the equation given. Now, before we start, it is very important that you have watched all of our other videos on linear equations and that we know what parallel and perpendicular lines are. Okay, so parallel lines are two lines that will never intersect. Now, this is an example right here. Two straight lines, and they will never intersect, even if they go along forever. Now, perpendicular lines are different. They're two lines that not only intersect, but form four 90-degree angles when they do. So, let me draw an example right here. So, let's say we have this line and this line, and they would form four 90-degree angles at their intersections. So now that we know the basics, let's move on. Okay, so let's start off with parallel lines. We're given this linear equation, which is y equals x plus 2, and as you can see, it is graphed right here. Y equals x, and the plus 2 shifts it up 2 up, and that's why the y-intercept is here at 2. Now, we're going to find a parallel line to this equation, and you might be wondering how. Well, that's what I'm about to explain. Now, in order for another linear graph to be parallel to this line, so y equals x plus 2, it must have the same slope. So, same slope. And a different y-intercept. So, different y-intercept. Now, you might be wondering why we need a different y-intercept, and the reason for that is that parallel lines never intersect. So let's say we had y equals x plus 2, for example, the same one. These lines would be on top of each other, and that means they're intersecting, and therefore they wouldn't be parallel lines. Now, the same slope, they have to have the same slope so that they never intersect. Because say we had y equals 3/4 x plus 2. Let's see what would happen there. Let's see. Y equals 3/4 x, and let's give it a different y-intercept. Why not? You would see that they actually, in fact, intersect here, and therefore they're not parallel lines. But if we had an equation with the same slope but a different y-intercept, so y equals x plus 4, you can see that they will never intersect because they have the same slope and a different y-intercept. So if you were asked to find an equation that will be parallel to y equals x plus 2, it can be any equation that has the slope of 1 and a y-intercept, so x, slope of 1, and a y-intercept that is not equal to 2. So anything, y equals x plus 100 would work. Y equals x plus 50. Anything would work as long as it's same slope, different y-intercept. So let's go ahead and spice this up a little. This will be a slightly harder example, but you will see where I'm getting with this. So we have this line, y equals 2x plus 1, and it is graphed over here. And we were asked to find a line that is parallel to y equals 2x plus 1. And as I explained before, it has to have the same slope and a different y-intercept. So y equals 2x plus whatever number except for 1. Now, they're also asking us that line passes through the point negative 2 comma 4. So it has to pass through this point. And now we're going to use point slope form in order to solve this problem. So if you haven't watched that video, go ahead and do that so you can properly understand. Now, remember, point slope form, the formula is y minus y1 equals m, which is the slope, multiplying x minus x1. Now, let's go ahead and use this formula in order to do this. So let me just write down the original line, y equals 2x plus 1, y equals 2x plus 1. So now y minus y1, so the y1 is going to be 4, because it is one of the points that this new line, which will be parallel to y equals 2x plus 1, will contain. So this would be y minus 4 equals the slope. And you might be wondering what the slope is. Well, as I explained before, for two lines to be parallel, they must have the same slope. So in this line, the slope is 2. So in this other line that will be parallel to y equals 2x plus 1, the slope also has to be 2, multiplying x minus negative 2, again, right here, which then this will become a plus. So y minus 4 equals 2, x plus 2, and then we distribute the 2. Y minus 4 equals 2x plus 4. We add 4 to both sides to isolate the y, and we would end up with y equals 2x plus 8. Now, as you can see, these two lines are parallel because they have the same slope and a different y-intercept. But now let's make sure that y equals 2x plus 8 does indeed pass through the point negative 2 comma 4. Let's go over here. So y equals to x plus 8. Now as you can see, they are parallel, and it does indeed pass through points negative 2 comma 4. So whenever you are asked to find a line parallel to another line that passes through a specific point, you use point slope form in order to solve for that equation, because you already know one of the points of that new line and the slope. So you can easily just substitute in the values to this formula and find the equation just like we did over here. Okay, so here we have another example. We are given this line, y equals negative x plus 2, and we are asked to find a line parallel to y equals negative x plus 2 that passes through the point 1 comma 3. So this point right here. Now, as I explained before, we already know that this new equation contains this point, and it has a slope. So m would equal negative 1. It has a slope of negative 1, since parallel lines must have the same slope. So now that we know one point and the slope, we can use point slope form in order to find this equation. So we would y minus y1, which would be the 3 since it's in the y value, equals negative 1, which is the slope, multiplying x minus 1, x minus 1. And now let's distribute the 1. And we would get y minus 3 equals negative x plus 1. We would add 3 to both sides to isolate the y. And we would get y equals negative x plus 4. Now let's make sure this works. So y equals negative x plus 4. So as you can see, they're parallel since they have the same slope and different y-intercept. And it does pass through the point 1 comma 3, as you can tell right there. 1 comma 3. There we go. So now that you know how to do this with parallel lines, let's go ahead and I'm going to teach you how to show this with perpendicular lines. Okay, so now let's talk about perpendicular lines. Now these behave a little bit different compared to parallel lines. So here we have an equation which is y equals x plus 2, y equals x plus 2, and we're asked to find a perpendicular line to that equation. Now there is only pretty much one big, really important rule, is that the slope of the perpendicular line has to be the negative inverse of the original one. And what I mean by this is, say we had a slope of 2, or 2 over 1, which would be the same thing. Now the inverse would be 1 half, because you switch the numerator and the denominator, 1 over 2. And the negative inverse would simply be negative 1 half. So now that you understand what the negative inverse is, let's analyze this equation. We have a slope of 2x. So the negative inverse would be negative 1 half. So this would have to be the slope of the new equation, which would be parallel to y equals 2x plus 2. And the y-intercept could be whatever you want. So in this case, the only thing that would have to be true is that the slope is negative 1 half. And then, for example, this could be a perpendicular line to that equation. Or this could also be another one. The y-intercept can be whatever you want as long as the slope is the negative inverse. So here I actually plotted the equation which has a slope of which is a negative inverse of 2, so negative 1 half. And as you can see, they intersect and they form four 90-degree angles. 1, 2, 3, 4. And therefore, these two lines are perpendicular. Okay, so now that we know the basics of perpendicular lines and how the slope behaves between two lines that are perpendicular, let's go ahead and do a more complex example. Now here we have an equation, y equals 2x plus 2, and we're asked to find a parallel line, perpendicular line, to that equation that contains the point 2, 3. Now, as I explained before, the slope of this perpendicular line has to be the negative inverse. So in this case, y equals 2x plus 2, the slope is 2. So in this new equation, the slope would be the negative inverse, which would be negative 1 half. So now we know the slope, this would equal m. Now we know the slope of this new equation, and we also know that it contains the points 2, 3. So once again, we're going to go ahead and use point slope form in order to finish this up. So remember, y minus y1 equals m pound, pound, pound. So now let's substitute these values in, and we would have y minus 3, because it's in the y value, equals negative 1 half, which is the slope, multiplying x minus 2, because it's in the x position. Now we would distribute this negative 1 half, and we would get y minus 3 equals negative 1 half x. So you can already see that the slope of this new equation is negative 1 half, which is the negative inverse of 2. So that way we know it's already a parallel line. Now we just have to make sure that it contains the point 2, 3. So negative 1 half times negative 2 is just 1, positive 1. Now we would add 3 to both sides, and we would get that y equals negative 1 half x plus 4. So as you can see, they are perpendicular since the slope is negative inverse of 2 and the y-intercept is 4. So now let's go ahead and see if this would work. So y equals negative 1 half. So negative 1 half x plus 4. So as you can see, they are perpendicular, and it does pass through point negative 2, 2, 3. So now you know how to do this with both parallel and perpendicular lines. You can apply this when you are asked to find a line that is either parallel or perpendicular to that original one that passes through a certain point. Now that does it for another video. Thank you for watching, like and subscribe, and see you next week.